guys, welcome to a new series of videos. This series is going to be on org mode support in Dogen. The objective of this series of videos will be to record the coding that we're going to do to support proper end-to-end or forwards and backwards, I guess, processing of org mode diagrams. What do I mean by that? I mean that at present, as I've demonstrated previously, we've got some initial support for org mode, and org mode is the future sort of representation that we're going to use for pretty much everything. So what we did is, as we always do here in Dogen, we just did things the easy way. This is just basically string dumping. We've got a very simple transform that takes a model and just generates this file. Which is fine, because all we wanted was to see whether, well, we wanted to research the feasibility of org mode. Let's double check we are recording. Also, let's double check that we have started the clock. And this is the guy. Actually, there's something not quite right here. We just clocked some time for. Here we go, just clocked it in the wrong place. Sorry, apologies, I just started by doing some review of the story, so this sprint, but it seems we've clocked it in the wrong story. So let's just fix that. Just for completeness, I'm just going to uncommit and recommit. Okay, so as I was saying, we have begun some work trying to understand what's required in order to have a slightly more complete org mode representation that enables us to read the org mode models and to process them as we do for dia, JSON, and so on. That analysis has been going on for quite a few sprints. But we finally got to a point now where I think the limitations of dia are just becoming a bit too annoying, and we just have to do something about it. Now, we don't really. One thing that's important to stress is org mode is very complicated, and the specification for org mode is vast. I mean, if we have a quick look at it, sure we have it somewhere. If I just look at this guy here. Open it in the browser. So as you can see, sheer size of the specification. I mean, it's very large, and there's a lot of the specification that relies on the fact that it's processed by Emacs. Although it's not the only editor that supports it, but Emacs is obviously where it was invented. So it is actually quite flexible and it does a whole lot of things. Now we don't really need Dogen to know everything about org modes. We just need Dogen to know enough about org modes in order to be able to recreate all the features they have in dia, and that's what we were after when we did our little exercise. Not sure what's going on with my eye. This little exercise you see here is to say, can you capture all the relevant properties of a dia diagram in an org mode representation such that there is no loss of information. I think we're going to find out that there's still a few bits missing here, but at least the major things are more or less under control. They're more or less captured. I'm actually just going to pause this for a second and see if I can sort out my eye. I'll be back in a second. Okay, apologies for that. So, as I was saying, the objective of this was mainly to try to see if we could find a structure that captured most of the properties required for a diagram, and try to do it as natively as possible in org mode. We didn't quite go as far as we should have. So for example, one of the things we wanted to do is we wanted references to be processed as links. We still haven't quite managed to do that yet, but we might leave that for a later installment of this work, because it's not really crucial to the first step, which is just to move from to support basic diagrams. And the reason why we want to be able to do that, just gonna open the window, it's a bit warm here. The reason why we wanted to do that is because tools like org-roam would then become available. Org-roam is pretty clever, and there's an ecosystem of tools in org mode. They're all extremely clever, and I think we just want to deploy those because they are probably be quite interesting to use those in the context of modeling. Nonetheless, the first approach is going to be the simplest thing possible. We just want to somehow capture this structure into a sort of a domain model representation. Now, we've already designed the domain model representation. I thought we had done this before, but I've been looking for diagrams, I couldn't find it, so we did it again over the last few days. And this is kind of a fairly simple, simplistic representation of an org document. We will now have to create the two transforms that convert this structure into a string and vice versa. Once this is done, we will then have to plug this new transform over here to the codec. Now we've already created some stubs, so we just have to use these stubs. There's one, and hopefully there'll be another somewhere around here. So that's the gist of the work. So this series of videos will be basically covering this sort of work. And so what we'll start off with today is, don't think we're going to touch templating, so you can close that diagram. So what we'll start off with today is we already generated a diagram, so we just create some unit tests. And also the other thing I may have not mentioned is there are many implementations of org mode. Okay, let me just rename some of these areas. We were working on them, but never really. Not sure what this area was for. Let's just leave it blank. So if we go up to the org mode area, you can see here we've git checked out a number of org mode implementations, some in C++, some in Rust, to give us some ideas. Interestingly, their implementations have got different characteristics. So for example, this Rust implementation created sort of these parsers, and the parsers seem to be mainly regular expression based. And the good thing about the regular expressions is perhaps we should be able to just reuse these regular expressions. Not all of them have been implemented, but they are fairly complex, and I'm not entirely sure we need this level of support. So this obviously will be a very complete implementation. And I guess the first decision we really have to make is what approach will we take for the parser for this. So we have three options for the parser really. We have the regular expression base, as you can see here. Another chap, which is a Brazilian chap in fact. Let's have a look. I think it's Felipe. Yeah, Felipe Almeida. He started some work here. And the work that Philippe done is quite interesting. It didn't go very far, but it did give us sort of the backbone of it. And his idea was to create a series of spirit parsers for org mode, which is an interesting approach because we are already using org mode, spirit for the parsing of attributes, and that means we got some kind of experience with it. We could perhaps just reuse these parsers as well. And finally, the third approach is to use a very simplistic approach, which none of these parsers do, which is to really just look for the things we want and ignore pretty much everything else. And we might even start by doing that really. So for example, what I mean by this is, if I take a model, we could literally just say, well, lines starting with those two characters are lines for an affiliated keyword, and then what we do is we basically just take whatever is up to the semicolon, the colon, and break that into two, and that becomes affiliated keyword. Then we could look for things with properties, either lowercase or uppercase, in between two colons, and then everything in it becomes the property drawer. And the drawer type will be dependent on the keyword used here. And if it is a property drawer, we can just split it into a key value pair, and so forth, right? And if we do that, I think there is actually almost nothing here that would not be captured by it. I mean, you wouldn't be able to have things like the date and all the sort of the wealth of information that you get from org mode, but we don't really have a requirement for that either. So maybe we should think of this as a two-pass exercise. First we just have a basic org mode support, and then in the future, as we start using more features of org mode and they become more relevant, perhaps we could upgrade this to a parser based implementation. So I think we're going to go with that, because I think that's just the easiest thing to do, and we don't really have a lot of time to spend on this, so best to just do it quickly and sensible way. Right, so let's just start by creating some tests then. We don't tend to create many tests around here because we don't have the time to maintain the tests, but when you are creating new code, it tends to help. Not entirely sure why I'm not allowed to go into my folder. I think one of the problems with this git dired is sometimes it goes a little bit funky. It doesn't really matter. We could actually we don't want Dogen. So if I take some other thing for which we have tests and copy these guys across. Okay, what do we do for this? We named it something else. Right, so having a better Emacs day already. Right, so right, so this is diet being clever here. Right, so we first name this correctly, then we try to go into tests and templating, copy a couple of things. Okay, now it's a bit healthier. And then, don't ask me why diet keeps on creating an extra buffer here, extra window. Right, now then, we just need one of these guys here. Okay, and the formatter, I think, for the templates is what outputs. So this will be, we need the parser test presumably. Yeah, here we go. So this is just basically an example of the parser for the template so you got, which also uses this very simplistic approach. So what we can perhaps just copy these guys here, and then we could just say right, one thing we did not do is we did not create a parser, we just created a transform. I think, to be fair, we probably should create a parser and just call the parser in the transform, really. Let's just create here another namespace. Some kind of helper. I mean, there's nothing stopping us from making a transform with all the parsing code in it. It just seems there are two concerns here. And I think I'll just separate the two concerns. So we just want something like parse, and the parse just returns entities model or documents, and the input is just a string. Right, so as you can see here, this parser will be very, very simple. In fact, to be honest, I might even go as far as saying, why not put this above? Just purely because I can then make a reference. Just to say that this guy really should point to this guy here. Right, so the idea then is, and this is you see one of the reasons why we're so keen on moving away from dia, because every time we make a change to a diagram we always end up spending quite a few minutes trying to work out what we think is the best way to represent things in the diagram. And this doesn't really I mean, it's fairly relaxing thing to do, but sadly it doesn't add a lot of value. So and you can literally spend forever trying to do the right shape. I think OCD people really shouldn't have diagrams because it's productivity sapping, I think. So there we are. I'm not sure why this is here either. So what we want to do then is perhaps even put the document slightly higher. Yeah, let's not get too involved here. This would have to do. Okay, so the parser generates a document, and the transforms would then use the parser. Now this guy should really be where this color is, E5E. It's a shame that we lost our support for the coloring script, and that automatically colored all the entities. Another reason we need to leave dia is we are doing too many manual things, really. Oops, what did we do here? And really, the whole point of this is to automate everything. So if you are spending a lot of time not doing things that should have been automated, it defeats the purpose slightly. Okay, right. So then, so the parser would have an entry point parsing a document. Then it will detect a few data keywords. Oh, the other thing you will notice as well is our parser assumes that the document will be more or less in the shape that we expect the document to be in. Let me just rename these guys here too. Parser tests. Oh, interesting feature of Dired. And then what we can do is we can in here Dogen.org.tests. This is the parser tests. Now I think what we'll just do is we'll just keep one of these examples because we don't really need all of them. Yeah, just the examples of things we want to parse. Probably will need to make sure we don't really reference templating here. In fact, to be honest, I might go as far as saying that no, actually let's just get rid of these guys. And then we just need a test example. That would do. Now I probably will leave the parse function here because I think that's a useful function. And we could should hopefully compile. Not sure why Mac is so verbose at present. Okay, so that compiles. Org mode has not been added to our list of tests, so that's why it didn't break. Probably need to do that. In fact, you need to figure out if there's any tests missing. I think we have a few, so let's have a quick look before we do that. So we have orchestration tests, and in here we test a whole lot of models, including all of the Dogen models. And so what we do is we just very carefully inspect our list of models. And just double check. So first problem we're going to have is not the same order. Perhaps we should make it the same order, I think. So first is physical. So this will be something like Dogen underscore physical. So let's just make sure that's the first test we run, followed by CLI. I'm just going to put this in the same order, just that in the future if we need to figure out if something is missing, it'll be slightly easier. Tremax is not very happy. CLI, then Dia. Followed by org. We'll skip org for the moment. Tracing. Actually, why do we have two Dogen Dias, I wonder? Okay, I think we made a mistake there. What we really meant to say there is Dogen is the very first model. Okay, right. So Dogen.dia happens to be the Dogen model actually. And we want that to be the very first one. And then Dogen.dia, the second. What are we doing for time? 23 minutes. So this video will mainly be the presentation of the task really. The cleanup and little else, because I think we're going to run out of time. We don't make the videos too long. About an hour and a half really should be the maximum. I think I'm going to have to disable LSP mode on this buffer because something is slowing things down. Let's see if it's just Tremax follow. Right, so Dogen Dia, physical, CLI, Dia, org which we're missing. Okay, this is actually quite annoying. Let's see if we can just close the buffer for a second. Refresh Tremax. And let's reopen the buffer. Something is not quite right with this buffer. I think the main thing really, to be honest, is that we have a lot of tests in this buffer and Tremax just gets a little bit sad when there's too many entries in the tree. So as we're saying, tracing after Dia. Just have to get out of here as quickly as possible. Oh. So that's tracing, followed by Codec. these codecs, although one of them, oh yeah, that's correct. And then text, which I think is missing. No, it's there. It's a good way to learn patience, I think. This, although I've been using Emacs for a long time, I'm afraid I'm not very knowledgeable about the Lisp side of things. Most Emacs users know how to their way around, and they'll be able to debug this kind of problem. That's kind of what you expected from you as an Emacs user. I think one of the problems people tend to find is when they use Emacs and there's something that doesn't work, they tend to think, oh well, it's not very well designed, it doesn't work, and they move on to another editor. And actually, really, what you're supposed to do with Emacs is, if something is not working correctly, you're expected to get your hands dirty and to then figure out what's going on. And that's a bit different from other editors, I think, where the editor is sort of a black box and you're supposed to just get on with the functionality that's available to you. I think in Emacs the ethos is you're a user but you're also a developer of Emacs, sort of thing. And I have been spending some time now trying to understand the fundamentals of Emacs in my spare time. Sadly, I haven't quite got to the Lisp debugging yet, so I can't fix these sort of problems. But the typical user Emacs now would kick off the debugger and would then figure out why Emacs is malfunctioning and then submit the patch. So templating followed by orchestration. And you can see why, is because Emacs is just basically a big library of text functions, really. The text editor is just an application running inside of Emacs. And there are many, many applications, so... Okay, so it seems like we're missing quite a few tests. Orchestration, utility... Right, so variability I've seen, yeah, there it is. So we're missing relational, identification, and org. Right, so first we'll just basically check this in as a reorganize the tests. I mean, I keep saying this, we should try to minimize the diffs, because when something breaks, it's nice to know why it broke. So we will just create the first commit, which is just these guys in the right order. Then we'll add org, relational, and identification. The idea here being that by running tests on the existing models, Codec that compiles. So let's just call these order tests, reorder tests in CMake inclusion order. Okay, and now we can add the missing tests. So at the bottom we have two. So the reason why we want to test Dogen by running its own models is that this then makes sure that Dogen is actually building this correctly across all of our supported platforms. Because of course you would think, I mean, we generate these models every other day really, so it doesn't add a lot of value per se from a Linux perspective. But it is useful from a perspective of every other platform really. So as you can see, we need to do some work in order for this to work, because we don't have paths for these models. So if I just go to the Dogen product, so if I just do the LSB workspace symbol, Dogen product. Oh. for some reason LSP is not actually very happy at the moment. I thought we had a session on LSP. Oh yeah, we do. Okay. Oh, okay. The problem was I was on the CMake file. LSP fine works. Well, to be fair, after all that, let me just type Dogen product, not HTTP. Sometimes Emacs has too many ways of doing the same thing, and you end up complicating things. Right, so let's just do something really simple here, which is add two entries here, one for relational and the other one for identification. And I suspect org was... well, let's deal with org in a second. And as always, we have to... why do we have... oh, because we have JSON models now. I'm actually not going to bother adding support for the JSON models because we are going to remove the JSON models. So we'll just stick to the dia models. The reason being that the JSON models were just giving us too much work, and since we're not really using them in anger, it's not that we don't want to support JSON as such. JSON may actually have its uses in the future, but it was costing us a lot of time to keep the JSON models up to date because there's bugs in the JSON implementation, and the bugs required manual intervention. If our codecs generated perfect JSON, then we would have just kept using those. But we don't have the time to fix the bugs, and I'm not entirely sure why that's failing. Path Dogen relational.dia. That sounds about right. Oh, did we forget to copy and paste? No, we just not spell relational. Right, so hopefully this will make this guy happier, and then we can return to our CMake file, look for dia, and in here we could just say that org and org. And as you can imagine, once we have proper support for org, we shall be copying and pasting all of these and run these tests for org. But that's at the end of this series. And now we just need to add the org model. Now I'm not sure if these paths here are in order either, which to be fair is going to also drive me nuts, so let's just fix that as well. So we have Dogen model. I think that's actually just the product model. Not clear. So let's have a look at the test again. Dogen dia. Okay, so first one should be Dogen dia, which is just the Dogen model itself, followed by physical. As you can see, I'm now actually going to end up doing 2 commits here, but in fact, to be honest, let's just skip that change for now and do that change after, because otherwise we're going to end up with more diffs than we need. Or presumably no. Okay, there's a problem here. We copied the wrong thing, I think. What we really mean to copy was this guy here. So it should be Dogen org.dia, because of course it's an org mode diagram in dia format. And so, not this guy, but this guy, and for now it doesn't really matter the order, because we're going to fix the order in a second. So let's just take that as is, and then let's just look for dia. Now you can probably part of my changes are definitely to do with OCD, in that you try to make things in the same order just purely because your brain needs things to be in order. But I also think that OCD ends up being a useful trait to developers, because if things are in order, you know where to find them, and you know where to put them when you're trying to add something new. So I think, and not clear to me whether programmers become OCD or whether, here we go, bingo. And that's what we expected. We expected a failure, so now we will generate all tests. Generate all models, I mean, and that now is going to give us the helpers that we wanted, and then let's just run all tests again. I think at present, okay, we're having failure on the tests. Interesting. Let's go to that test and try to understand the problem. I think we just yeah, we just got a little bit trigger happy here. Yeah, so it's not clear to me whether programmers become OCD because of their job, or whether being OCD person is useful as a programmer. So we develop, well, it filters out for people that tend to already have these kind of traits, because I think that it is very helpful for you to keep order when you're coding. Right, so what we'll do is we will just check this in. We'll just generate the parser. Then what we'll do here is we'll just say utility add. So add, what models do we had? Let's go back for 1 second. We added org, relational, and identification. So utility add org, relational, and identification models to product. And then finally, we could then say orchestration, add missing models to tests, missing dia models to tests. And at that point, we probably want to, well, I will reorder things in 1 second, but just before we do that, let's just do one more change, which is here. Let's just make sure that we add tests. And let's make sure the tests, yeah, so templating should be org. I think there's only one change really. Now let's run all tests again. And what that's going to do is just run our stub tests, which hopefully works. Yeah, that's good. So let's just call this org add stub test. Right, okay, so that gives us in a good position to start. And then just before I forget, let's just very quickly solve our problem, which is the order of these guys here. What I tend to do with these things as well, most of the time, is I tend to use commands like the sort command, because then at least you have a guaranteed order. Well, a guaranteed order, no, but a well-defined process to order things. But we didn't do that originally with the makefile, so we'll just take on whatever the makefile tells us. It shouldn't take us too long. So the gen.dia is the very first one. Physical CLI org yeah, so what this sort of ordering tends to do is it tends to make things easier because you know what you're looking for. It's not to say that we always do that, because of course, as you can imagine, it was not in order in the first place. So clearly we were slightly distracted when we added this original. Logical orchestration. Logical templating orchestration utility variability. Now we have a codec.json here, which we don't need anymore. Tracing should be next to org. Orchestration utility variability relational and identification. We will reorder the JSON ones just because well, just because we're here, I guess. Actually shouldn't, you know, we're going to remove them at some point, but well, to be honest, it's not clear that we're going to remove them, really, to be fair. If I'm honest, we probably would like to reactivate JSON support if it's possible to have JSON support. Actually, we're missing it. Oh, yeah, that's the first one. So if we could have proper JSON support without having to manually massage the diagrams, then it would be nice to have JSON support, to be honest. Because we mentioned that JSON will be very useful. For example, it would be useful to have a JSON document that we could push to a database, and then we could use Postgres queries on that JSON document, for instance. I mean, that would be really useful. So it's not the case that we are going to completely deprecate JSON support. It's just that until JSON is working properly, it's just not worthwhile maintaining it maintaining it up to date with the dia documents, because what we wanted to get out of JSON we more or less already got, which is we wanted to make sure we didn't hard code anything for dia. This was very important. The reason really why we wanted more than one codec type, it was just to ensure that when we are doing things, we are not just simply doing it on the back of you know, it's dia, so it works dia and that's it. That would not be ideal. So okay, right, so I just need to concentrate here for a second, otherwise this will take us forever. Physical. Org tracing. Codec. Now we know for sure there is no JSON anymore, so let's get rid of that. Text. Logical. Orchestration. Utility. Templating is after logical. Logical templating, orchestration, utility, variability, relational, and identification. So one other thing that's probably worthwhile mentioning as well is that you may think some of these exercises are a bit boring and time wasting and so on. And to be honest, I'd agree with you. The thing with programming sometimes is that you need to somehow there's this fine balance between doing certain activities that are productive towards the end goal, and other activities which are just maintenance. And finding the right balance between these two, you can't really do all the maintenance in the world, because you have real work to get on with, and this is particularly a problem if you work for a software house. So we don't really have huge amounts of time to spend to do maintenance work. So physical is at the top next to this guy. So in a software house you don't really have hours on end to do maintenance work, refactoring work, that sort of thing. So you tend to be very focused on the task at hand, and so things like this that I'm doing at the moment, for example, you wouldn't do that in a normal software house, because I mean, you're going to have to explain why you spent X amount of time ordering things in a certain order. So you end up just basically doing the thing that needs to be done. Not negligently, if you see what I mean. I mean, you would do it best to your efforts and so on, but there is a degree to which you can be OCD if you're working for a software house, and there's a point at which it's no longer feasible for you to do that, because you haven't got the time to do that. And so what you really need to do as a developer, I guess, is you need to be able to sort of work out the right balance between the OCD nature and the deliverable at the end. And then what happens is that over time, with experience, you end up learning that certain this is not supposed to have gone here. So certain things can be done, and certain things can be delayed for some other time. Right, so tracing. I'm sure we had org a second ago. So where are we? Physical. And there's org. So tracing will go here. CLI next to physical. I wonder if okay, it's not going to work. It'd be nice if you could just basically hide all of the levels here, make this just a one-liner, but you could have to do it manually. So, right, where are we? Physical, CLI, dia, org, tracing, and then codec. Text. And sometimes another thing is you start doing some refactorings and realize actually this is going to take a while, and then you end up not going through with it purely because it's more than what you expect, which is fine. This happens as well. It's almost like you have to contain your level of ambition. Utility, perhaps variability could go here. Relational and identification. Okay, so that's the dia ones. Now we just move over to the JSON ones. In fact, I'm just going to put a comment here. Dia paths. And we could just have the JSON ones here. But the key thing really as a maintainer of a project is what you're really looking for is every time you touch the code, you just want to make it slightly easier for yourself. That's really what you're looking after. And same thing in a production environment, in a professional environment. You won't be able to fix all the problems of the world, but if you could just make that bit of code that you're touching right now just that tiny bit better, these things accumulate over time. And it also means that next time you touch that code, It'll take you just a little bit less time to understand what's going on. And so that's why it's useful to, even though it might look a bit like time wasting, it's useful to do these sort of exercises, because what we tend to do is, as you probably noticed a second ago, we tend to remove things that shouldn't really be there anymore. We tend to just do a few bits of tidy up as part of the reordering. And those few bits of tidy up will ease maintenance over time. But of course you can't, you have to control the amount of tidying up you do, basically. So that's going to be the tidying up for today, I think. Now we will skip perhaps some other chances of tidying up, I think. It's almost like there's a tidy up budget, I guess. So where are we then? Text. So codec, text, logical, templating. And that's another reason why I like to have stories that tell you what you're working on. So we should have really probably created a story for this, because then when you look at the sprint log, you'd say, oh yeah, I spent X amount of time on tidying up. Dogen die, I think this will be close to the top. So then orchestration, utility, and variability. So we're not going to bother adding the missing ones to JSON just yet. The reason being that we're not going to use them right now, and we don't want to add things that are not being tested. So just to ensure that we're not going to make mistakes and break something and then not realize that we did. I think we might be on a Portuguese keyboard, perhaps. Oh, there we are. Right, so utility, reorder. Actually, we've already created a message with some reordering, didn't we? Where was that? I can't find it. So utility reorder models in the same order as CMake lists. Okay, fine. So that was a little bit of time wasting there. Now then, what are we doing for time still? 53 minutes. Now then, so the actual work we're supposed to be doing. What we're going to do here is we're going to go back to our test. And we're going to have the parser next to each to the work. So parser should be, okay, would do. I think the parser will probably just need dogen.org. Not sure why we can't complete. Well, anyway, let's just go to dogen.org types entities documents. HTTP perhaps. And this guy will just be string. Now, what is wrong with dogen.org? I thought that was sensible enough. It could be actually that the LSB, it's never clear to me. Let's just do a quick look at the compile commands, because sometimes, yeah, as you can see here, there is no document.hpp, and I suspect, oh, actually, document. There is document.io, so right, there we are, document.cpp. Okay, so it has picked up the latest org stuff. Did we just do some simple path error? So dogen.org types entities documents. Okay, that looks good. Okay, I think sometimes LSB just needs a bit of a restart. Not clear to me. I think most of the time LSP actually picks up changes to the compilation file, compilation commands, and we don't really have to restart it. But other times, don't ask me why, it doesn't seem to do that. So parsers. It might take a little while to warm up now. So parsers, a string containing valid org node document into its domain representation. And so here what we want to do then is to just follow our little. Now the only problem of course is that when you restart LSP everything slows down a bit. Let's probably make this static because we don't really need a lot of state, I don't think. Right, so there we are, static, and then all we need to do is to give it a really simple implementation here. And oh, not that simple. So all we're going to do really is to say, well, just retrieve a document. As you can imagine, this is just to get us going. Right, so this awfully simple implementation of the parser will be sufficient, and our tests. And then what we can do is, well, I like to always start with the simple possible case. So empty string. Right, so we need to reactivate this guy here. Perhaps we could say, give us a parser, and then the parser could be Dogen org documents or entities documents parser string, and then this guy here will be a helper. Parser p.parse, right? So all we need to do in our very first instance is if you parse an empty document, you ended up with, well, pretty much empty everything, I guess. So something like, so this is the document. We expect to be document.field_empty. And basically just set up a few expectations here for this case. Nothing special. Lines should be empty as well. And section should have no blocks. Right, very simple test, doesn't do anything particularly special. Just want to make sure that when you give it an empty string, we end up with an empty document. And what we'll do now is we will make sure, actually to be honest, we probably will check this in as is, but so let's just say something like you could spell. So we're just going to implement the skeleton for the parser. And now, let's just, before anything else, let's just add some logging to our parser, because actually we probably now need to start doing projectile buffer, because we have so many projects open. And in here, if we pick up pretty much any CPP except for tests, such as the assistant, for example, we can get a few things of use. So we're going to need a logger. Um, and org helpers parser. Then we can just log something like parsing org document. Now we could put this as trace because I think we don't really want to write the documents every time. But if we are looking for problems, it's useful. So there we are, very, very simple. And then, of course, what we should do as well is make sure for now, in our parser tests, that we are logging to debug. This is actually not quite accurate. We are probably just, I think it's actually, we should probably call this something else because this doesn't mean we're logging in debug mode. It just means you're actually logging. But anyway, there we go. In fact, the other thing we should also do is we should probably say something like run dogen.org tests. So we don't have to run every single test, so we just run the one test. And then if I then jump over to the logs, let's see what we get. So log org parser tests. Okay. Okay, so as you can see, that wasn't particularly useful, so we probably should do something like make sure the string is contained. Okay, so now we've more or less set up to run our little tests, because now you can see the output and we can write the tests, and away we go. Okay, so let's then start to, well, let's get rid of a few of these things here. First, we always like to have that at the top, I think. Now, so let's start with the simple case, which would be so a document normally comes up with some headlines. I wonder if we should just copy these tests from one of the implementations. Let's just have a quick look. It might just make life a little bit easier. Let's have a look if there's tests here. Auto tests. Okay, here we are. So there's a number of tests here. So okay, so clock entries, simple tree. Right, let's start with something like. Okay, so first we started with an empty document. We should start document without headlines, right? So, oh, interesting. Okay, that was interesting. I didn't even notice, but there. No, okay, fine. That's just text, so that's fine. So this will do for our first set of tests. So the first thing we'll say is headline less document. And so the headline-less document, well, single line document. Right, so the single line document will be just that. And now we'll repeat the tests. And we expect. So the test name was not correct. It's an empty string. It tests an empty document. Righty. So now we could say, well, actually, to be honest, these tests become a little bit boring. I never quite know how to name tests like this, because I like the given when then sort of way of doing things, but sometimes you get a bit boring really. So single line document results in, so given a single line document, we end up with in section with one line. Something like this, right? So a single line document, which is our input, results in document with section with one line, but I mean, just make the name a little bit smaller. So I like the string being the same as the beginning of the test name, because we could just copy and paste. Now, we don't expect any affiliated keywords, so that's fine. We expect drawers to be empty, we expect headlines to be empty, but we don't expect that to be empty, so that should fail. Now, what we need to do in order to do content is we're gonna have some kind of big loop in our parser. Actually, I wonder if we should just create a new area here. Perhaps this would do. And we can just have the parser HVP and the parser.cpp. We'll just do that here. And no, actually, to be honest, it doesn't really matter. We could just do it from here. So it's fine. We'll just leave it as is. So how is the parser going to work for these cases? So what we want to then do is to say, well, if you just have, well, to be honest, it's almost like this is the negative case, because what we're going to have to do is you're going to have to detect affiliated keywords, drawers, and headlines, and everything else just becomes part of the section. So probably the best thing to do is to do something like well, actually something like we've done before. Let's have a look at what we've done for stitch. We must have something around here. Some kind of parser. And presumably we will, yeah, here we go. So right, so something very simple. We just loop through the lines. As you can see, this is not really a parser in the sense of, you know, complex parsing. But what we find though is that we found that actually a lot of times something simple would do. So why make it complicated? We could go and create a proper full-blown parser that involves proper parsing technology, but if at the end of the day all we're doing is we don't really need an output line, I don't think so. We don't really need this state machine just yet. We do need an input line. We will parse the input line, we bump the number of lines. I'm not sure what that's going to be used for, but I'm sure it will be useful. And then we're going to have a bunch of ifs here. And the else of those ifs is going to be to add to the document section, presumably. So r.section, and what exactly is a section? Okay, so we need to know that we're currently in a text block. Yes, I think I might have to be honest, I might require a little bit of non-recording time to actually think this through. But the gist of it is we need to remember where we are. So for example, if you are reading a block, I mean, we created this notion of a text block that doesn't really exist in org mode, but it's just to give us the notion of just gathering text that is not associated with anything else. But of course you have to remember that you're reading an org mode document, and you need to keep track what was the last thing you did. So for example, at the moment we're appending to a text block, but if suddenly we find a block of another type, we should start appending. We should create a new block type. We should slot that into the section, and then we should then start appending to this new block type. So basically, we need to detect the end of block condition, and then append to that block type. So this is actually going to require a bit of concentration. I don't think I can do this while recording. But anyway, what we'll do is we will stop the video here. I mean, you got the gist of what we're going to do now. It's going to be very similar to what we've done here in our very simple stitch parser. What it does is it detects the blocks, and it uses, we didn't really bother creating a proper state machine, but you can see that that's what we're trying to do here. We're basically detecting what kind of, where are we with the context. And every time we detect a transition, as you can see here, we're detecting different kinds of things via very simple string comparisons. And every time we detect a transition, we flush the existing block, push that over, and start a new one. And so we need to do exactly the same thing here. I think. However, I think I need to just sit down with a whiteboard and just work this through. And once I got to the point where the skeleton of it is there, it will be very easy to continue, because then all we need to do is to add more test cases and evaluate that the test cases are actually producing the right result on the output. So what I'll do is I'll just go offline for a little while, just to get the skeleton of this of the parsing code, and then I'll come back once we get to the point where it's more mechanical, and I'll just describe what I've done. Okay, thanks for watching.